Hey everybody, this is a video to show how we can solve all variables of a series resistive circuit using Ohm's law and Kirchoff's voltage law. So here on the board you can see that I have three resistors that are connected in series. Resistor 1 has a value of 5 ohms, resistor 2 has a value of 10, resistor 3 has a value of 12 ohms. We know that this is a series connection because the load side of resistor 1 is directly connected to the line side of resistor 2. The load side of resistor 2 is directly connected to the line side of resistor 3, providing only one path in this specific resistive circuit. So here I have the three resistors wired in series with an applied voltage of 120 volts. In a series circuit, it is true to say that resistances are additive. So resistance total equals R1 plus R2 plus R3. Resistance 1 is 5 ohms plus resistance 2, 10 ohms, plus resistor 3, 12 ohms. This gives us a resistance total of 27 ohms. Now that we have our resistance total, we can solve for the I total current in the circuit using Ohm's law. So the formula for Ohm's law is I total equals E total over R total, which is 120 volts, your applied voltage, E total, divided by our resistance total, which we just added to give us 27 ohms. This gives us a total current of 4.44 amps. So that is the value of current that will be flowing through this circuit. 4.44 amps of current. In a series circuit, current only has one path. Therefore, it is true to say that I total equals IR1, which is the same value, which equals IR2, which equals IR3, and would go on and on if we were to continue to wire resistors in this way. In a series resistive circuit, Ohm's law is constant. In a series resistive circuit, current is constant. So using Ohm's law, we can solve for the individual volt drops that are found across each individual resistor. And we can do so using our VR1 equals IR1 times R1. So the current through the first resistor, we calculate it to be 4.44 amps times 5 ohms of resistance, and that gives us a voltage of 22.2 volts. So if we put our voltmeter across this first resistor, we would read 22.2 volts. Across, meaning in parallel with that specific load. Now we would apply the same formula to the second resistor, and we would have 4.44 amps again, being your constant series circuit value, times the resistance in the second resistor, and that would give us the volt drop across it, and that would be 44.4 volts. So if we put our voltmeter across resistor 2, we would read a value of 44.4 volts. Okay, and then we will do the same Ohm's law formula on the third resistor, IR3, so 4.44 amps again, series circuit, current is the constant, times the resistance of the third resistor, which is 12 ohms, and that gives us a calculated volt drop of 53.28 volts. So if you were to put your voltmeter across the third resistor, you would read 53.28 volts. And that leads me to the last law that's applicable to the circuit. So Kirchoff's voltage law is true in a series resistive circuit. Kirchoff voltage law states that the volt drops equal the applied voltage or volt rise. Essentially, E total equals the volt drop across resistor 1 plus the volt drop across resistor 2 plus the volt drop across resistor 3. So if you were to take the 22.2 volts added to the 44.4 volts added to the 53.28 volts, you would in fact come up with 120 volts. So 22.2 volts plus 44.4 volts plus 53.28 volts, equaling your supply voltage, or 120 volts.